carefully in this today, okay? Okay, so to begin with, let's look at what we mean by a factor tree and the greatest common factor, okay? That's something usually you learn sometimes elementary school, sometimes middle school, but it's important that you understand this before you know how to factor, okay? We start doing the algebra. Okay, this thing right here is a factor tree. I see some students who have told me they've never done this before, and it's an important thing to do. It turns out that any number can be written as a product of prime numbers, okay? Now, a couple of things that you might want to write down if you need to. What is a prime number? It only divides by the number 1, which everything does, and the number itself. So the first prime number is 2. 2 times 1, that's all you get. Second one's 3. 3 times 1. How about 4? No, 2 goes into 4, so that's not prime. How about 5? Yeah, 5 and 1. How about 6? No, 2 goes into it. 3 goes into it, okay? 7, that's prime. I'll just go take it out a little bit. 11, 13, 17, 19, and forever, and that's good enough. Prime numbers go on forever. We know that for a fact. It's proven. We know that. They don't come to an end. There is no such thing as a biggest prime number. So you want to kind of know that from your background what primes are. And this factor tree, what I'm doing is I just started off by saying 9 times 6. I just find 2 numbers that multiply to give 54. Then I can break the 6 into 2 and 3, and see those are prime numbers. And I can break the 9 into 3 times 3, and those are prime numbers. So it turns out that 54 is the same as 2 times 3 times 3 times 3. Okay? Now, I'm going to show you another way. You don't have to write this down, but you could also go 2 and 27. 2 times 27 is 54. 2 is prime. 27 is 3 times 9. 3 is prime. 9 is 3 times 3. Look at this. I got the same answer. I got 2, 3, 3, 3. Just like I got there. So no matter how you do it, that factor tree is going to get down to the same answer. Okay? And every single number you can do that on every single number. Okay? Which is interesting to me that prime numbers are what builds every other number. That's kind of weird, but that's the way it works. Okay? So what I'm going to show you is using that strategy a couple of times. What we're going to work on and mainly review here today is what we mean by a greatest common factor. First thing that I would want a student to do is your first thought process is, can I do this in my head? That's your ultimate goal, is 90% of the time be able to do that in your head. Now I'm going to show you kind of what I mean by that. The greatest common factor, all it means is it's the largest number that evenly divides into 12 and 18. This is where I'm saying do this in your head, okay? The numbers that go into 12 are what? Like 1 and 2 and 3 and 6 and 12. Which is the biggest number in this list that divides into 18? 6. Okay, so 6 goes into 12 2 times, and then 6 goes into 18 3 times. So that would mean that what we would say is the greatest common factor of 12 and 18 is going to be 6. Okay, that's your ultimate goal, is to be able to do that in your head. But you're not always going to be able to do that, and if you can't do it, you have to have a strategy to do that then. Okay? So that would be kind of the way that you would do that in your head. Okay, so let's look at this next one. We're going to do the greatest common factor of 180 and 150. Okay? If you have trouble doing it in your head, and this depends on your skill with numbers, it really does. I'm going to do this one a different way because those are pretty big numbers. So let me show you how you can do this with factor trees. So you need to write these factor trees down, and then I'll take you through the rest of it like this. Okay? So if you haven't done a factor tree, they're easy to do. What are 2 numbers that you think of that multiply to give 180?
16 and 30.
Okay, I was thinking 18 and 10, but I don't care. We can go any way we want to, except 1 and 80. Don't do that. I see students do that. That serves no purpose. So you have 10 and 18. I try to get close together. What are 2 numbers that multiply to give 10?
5 and 2.
5 and 2. And those are prime numbers, so you can't go any further. When you get a prime number, circle it. You're done. Okay, one possibility on 18 would be 2 times 9. 2 is prime. Okay, 9 is 3 times 3. That's called the prime factorization of 180. So what I'm going to have you do is just write down that 180, and kind of do this in order. It's 2 times 2 times 3 times 3 times 5. Okay, that's called the prime factorization of 180. Okay, they're all prime numbers, and they multiply to give them. Okay, 150, why don't we do 15 and 10? Okay, and let's see what we get. Now 15, what are you going to use? 3 and 5. 10, what are you going to use? 2 and 5, and that's it. That's as far as you can take that. So you would end up having 150 equals 2 times 3 times 5 times 5. Okay, I'm just writing them order because it's easier to see. Now when you're doing a greatest common factor, what's going to happen on this is you just do this. You just see what's in common. Okay, there's a 2 in common, so that's part of your answer. What else is in common? There's one set of 3's in common, so that's part of your answer. And what else? One set of 5's. Okay, so it would be just whatever's in common, put them together and multiply them. So 2 times 3 is 6. 6 times 5 is 30, so that means the answer to this problem is the greatest common factor is 30. Like that. If you can't do something in your head, to me, that's the way to do it. And that's the way to always do it if you can't do it in your head. Now, let me show you why you're right. Okay, I'm big into checking because that's how you understand stuff. So if you want to find out if you're right, what you do is you just take these two numbers and you divide it by 30 and you look at the result. Okay, and you can do a calculator, you can do this in your head. 18 divided by 30 is actually, 180 divided by 30 is 6. 150 divided by 30 is 5. So first thing they have to come out equal, okay, or even, no decimals. Now the other thing I want to ask you is, if you look at 6 and 5, can you think of any number that evenly divides into 6 and 5? There is something. 1, exactly. So if that's true, if the biggest number that goes into these results is 1, that means you succeeded in getting the greatest common factor. Okay? So the idea on that is if you did the greatest common factor of 6 and 5, you would get 1. And since you do, you're right. Does that make any sense? Okay, does the factor tree make sense? So I see some students tell me they've never done one before. Okay, if you haven't, they're not hard to learn, and they're very, very useful when you're working on factoring. Okay, so that's kind of the general strategy. Either try to do it in your head or try to use prime factorizations like factor trees. Any questions? Okay, let's move to this second page and let's do kind of what we're after with the algebra now. Now, most of the time, you're going to be able to do this in your head. So what you're trying to do, whenever you factor, you're creating a multiplication problem. When you get the answer of this problem, when you multiply it out, it's going to give you 7y plus 28. So here's kind of the idea on this. The first thing you want to look at is you want to look at 7, and you want to look at 28, and you want to figure out the greatest common factor. Hopefully you can do that in your head. What is it? 7. 7 goes into 7, right? 7 goes into 7 one time, and 7 goes into 28 4 times. Okay, that's what you get. Okay, so that would be the greatest common factor. So what you want to do is you want to do this. So you just write down the 7, and then you write down a blank parenthesis. Okay, now you can either do this in your head, or you can do this. I don't care which. Your ultimate goal is to do the rest of it in your head. And with practice, it'll be an easy thing for you to do. So what I'm going to do is just write down the problem I'm trying to factor, and I'm going to divide everything by 7, because that's the common factor, and whatever I'm left with is what's going to go in the parentheses. So that's just going to be a y, then 28 divided by 7 is going to be a 4, so that means the answer is 7 times y plus 4. What we've done is we've created a multiplication problem. Okay? Now, how do you tell you're right on this? You multiply it out, right? You can do this in your head, guys. Okay, if you do the distributive property, what do you get? 7 times y is 7y. 7 times 4 is what? 28. We're back to the beginning, so we're right. 100% every time you factor anything, you can tell you're right. Okay, and you want to take advantage of that. So what I did, essentially, is figured out the common factor, and that greatest common factor goes in front of the parenthesis. Then you got to figure out what goes inside. Does that make any sense? Guys, that look like something you've done some point in time in your life? Okay, all right, this depends. Okay, let's look at 13 and let's look at 26. Okay, now one thing you can do on this is it's always a good idea if you don't see this to maybe just try the smaller number. So if I did 13 divided by 13, I'd get 1. And if I did 26 divided by 13, I'd get 2. So that's the greatest common factor on those is 13. So that's step 1, is to figure out that greatest common factor. Step 2 would be write the 13 and write a blank parenthesis like this, okay? Now this time try to do it in your head. This is your ultimate goal, is do it in your head. What do you multiply 13 by to get 13y? Y. Okay, what do you multiply 13 by to get 26? 2. So you can do it that way if you want to. You can just do it in your head. If you don't want to do it in your head, this approach will always work, and some students, this is what they settle on, is just doing it this way. So 13 over 13 is y, 26 over 13 is 2, so that means the factored answer to that would be 13 times y plus 2. Can everybody tell that's right? In your head? Okay. Okay, let's wrap up here with one last situation. I want to do 3, and then I'm going to have you just do a few of these, okay? I'm not going to do 4 and 5. We'll save that for next week. So if you have 2 and 8, the biggest number that divides into those is 2. So the greatest common factor is 4. So we'd have a 2 here, okay? That goes in front of the parenthesis. If you divide both parts of that by 2, what's left over? Y plus 4. There's your answer. Okay? Can everybody tell that's right? Okay, just distributive property. You guys done lots of distributive properties, okay? All right, here's what I want you to do. We got a couple minutes left. I would like you to do let's see if you can at least get just those. Just those. Just try those. You need to use a calculator too. Like if I look at that 19 and 76, my inclination would be take my calculator and take 76 divided by 19 and see if it works. Okay, just try it like that, and we'll see if we get these correct here then. And your answer is going to have one set of parentheses, and it's going to have a number in front.
So how do I deal with the square?
What's that?
How do I deal with the square?
Don't do that yet. We'll do that next week.
Oh, which one are we on then?
I want you to skip to 6, 7, and 8 and try to do those. Because that's another topic. I don't have time to do that. Okay? Again, you can use a calculator on these. Like I would try 76 divided by 19. I think that's 4, isn't it? And then you could try 81 divided by 21. As long as it comes out to be a whole number, I always tell students to try the smaller number and see if it goes into the other one. And if it does, then you're pretty much ready to go through and get it done then. Okay. Okay, now let's see. I'm about out of time here, so let's go ahead and do this. The greatest common factor of 9 and 18 is 9. Did anybody put 3? I always see students do that. That's okay. I'm psychic. I know how people make mistakes. That's very common. So 9 is what would go there. Then just divide everything by 9. So that would cross out. That would leave a y there. 18 divided by 9 is 2. That's the answer. And then just in your head, multiply it out and see if you're right. See, that if you used a 3, your answer probably checked, but it wasn't the biggest factor. You always got to pull the biggest out. This one, I think 19 works. Okay, so you go like that. 19 divided by 19 is y. What was 76 divided by 19? 4. Problem done. Okay. This one worked like this. 21 worked on this one. So 21 divided by 21 is just y. 84 divided by 21, that's 4 also, isn't it? Okay. So that's it. And you guys won't have much trouble with this type of problem. What we'll work on next time is a little bit more advanced idea to it, but generally this goes pretty well for students, okay?